already talked about what makes a triangle congruent. Okay. So in our triangles, how many corresponding parts were congruent? 3 angles and 3 pairs of sides. Today, we're going to talk about proving triangles are congruent. So they said, hey, triangle ABC is congruent to triangle DEF. But today, we're going to use 2 theorems to prove and be able to write that congruency statement. So our first theorem is our side congruence. So basically, if all 3 side pairs are congruent, then our triangles are congruent. So when I look at these triangles, somebody give me a congruent pair of sides. Sides. So it's only 2 letters. AB, okay, so we say AB. And what is AB congruent to? Don't do it again, rascal. Who is AB congruent to? DE, how do you know, Sean? What do you mean it's a side? How do we know AB is congruent to ED? The tick mark. They told us they were congruent. So we can say AB is congruent to, sir? Or DE. Let's go DE. Yeah, thank you. You're good. Yeah, it does. That's our first side relationship. Now, to be able to use side, we've got to be able to show that all 3 pairs of sides are congruent. What's another congruent side relationship? Okay, BC and EF say C is congruent. And then what's our final congruent side relationship? AC is congruent to DS. So do we have 3 pairs of congruent sides? We do. So because we have 3 pairs of congruent sides, we can write a congruency statement. So like I told you yesterday, the first one is always in alphabetical order. So we'd say triangle ABC is congruent to who? D triangle DEF. Because it could be an angle, or it could just want to be a specific. All right, so y'all tonight, you're not going to do a whole proofs, but I think us practicing is great and a good practice for you. For your homework, you guys are really just going to harp on making sure that my parts are lined up, making sure that I understand what sides are congruent, and then tomorrow y'all will do proofs on your homework. But tonight, I really want y'all focusing on the yellow, the blue, and the green stuff. Just start to identify. So given that PQ is congruent to ST, QR is congruent to TR, and R is the midpoint of PS. So let's label our given pieces. So what we know is given to us. Okay, PQ is congruent to ST. So let's go to our diagram on the right and let's label that piece. PQ is congruent to ST. And that's in that yellow right there. Good. What else was given to us? QR is congruent to TR. And we're going to go double tick marks. How come it's not showing up again? Golly. Come on, internet. Sorry, Hannah. Come on, man. I ain't got time for your shenanigans again today. That IT sends out this survey about what's working. All of a sudden, stuff starts breaking. They sabotage me. Saboteur. Come on, baby. Come on. Come on. Grandpa needs a new bag of shoes. Hit the what? I can't use the exclamation mark because Hannah can't see because my camera's broken. It didn't work. I have never thrown a chair. Because that's not good.
That's actually false. She threw it in my old car.
What are you talking about? All right. So we've got PQ is congruent to ST. We mark that with a single tick mark. We've got QR is congruent to TR. We mark that with a double tick mark. How come I use a double there instead of a single? I've already used a single. And we don't necessarily know that RQ is congruent to the other ones. Okay, and our last piece of given, we've got to be able to reason about what is happening. So when they say R is the midpoint of PS, what are they telling us as fantastic mathematicians? R is, so when I look at R, this point is the midpoint of this segment. And what does it mean to be a midpoint? Okay, what does it mean to be in the middle? That would be segment addition postulate. That why are they equal? Yeah, the definition of midpoint. So because R is in the middle of segment PS, each segment is then congruent to each other. You just got to smack it a little bit. It works. So that's our blue given. So when we look at number one, well, now you're working good. PQ is congruent to ST. How do we know that? Nope. Given. Can't write highlighter, dummy. QR is congruent to TR. How do we know that? You gave it to me. R is the midpoint of PS. How do we know that? They gave it to me. PR is congruent to SR. Definition of midpoint. Look at you guys go. Definition of midpoint. And lastly, why is PQR congruent to STR? Side, side. So we look at it, guys. So this was a side, this was a side, and this was a side. So we're going side, side, side congruence. And you can just put SSS. That congruency statement was created because we proved that three sides were congruent to each other on the separate triangles. All right, number two, JL is congruent to NM. K is the midpoint of JN and LM. Prove JKL is congruent to NKM. So what we're going to mark our given on our figure first. So we got JL and MN. JL, MN, those get a single tick mark. Why'd I give those with a single tick mark? No. How come I gave those a single instead of a double or a triple? This is the first one. Does it matter how I label it? No. Just that they match. So don't let that trip you up. Now, K is the midpoint of JN, but K is also the midpoint of LN. So this point K is in the middle of both segments. So what's that tell me as a genius geometry student? What's that? We could, but we don't necessarily know that they're the same. We just knew that it's cut in half. We're not using any angles yet, but I like that you see it. So if K is the midpoint of JN, so if this K is the midpoint, what does that tell me about those two segments? They're congruent to one another. So JK and KN, what color did I use for that? Green. All right. And then we look at the next piece and it says K is also the midpoint of that segment. What's that tell us about LK and KM? That those two segments are also congruent. So we don't necessarily know that the blue is congruent to the green, although eventually we'll be able to prove that. Oh, yes. So guys, on these ones, it's imperative that we mark our diagram before we even start moving on a proof. So first one, how do we know JL is congruent to NM? Hannah raised hand. What does that mean? Hannah, what you got? Hannah?
Say it again.
Did you need some help?
Oh, no, sorry. I didn't mean to raise my hand. I can
Oh, I was very confused because I've never seen that before. That was pretty cool.
Oh, sorry.
So let's Sam. All right. JL is congruent to NM. How do we know? They told us. K is the midpoint of JN and LM. How do we know? They told us. Don't do it, you rascal. Ah. Slippery Pete. Dang it, Peter. Come back to me from a faraway place where this thing is a giant disgrace. Come back, come back, come back from the edge, my friend. Do, 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 do. Hey-o, we're back. I was serenading it, it made it work. All right, so how do we know K is the midpoint? They told us. How do we know JK is congruent to NK? Nope. How did we, so that's our green. Yeah, so the K being the midpoint is what makes those two segments congruent. So definition of midpoint. How do we know LK is congruent to MK? That's our blue. How do we know that? Yeah, same thing. Definition of midpoint. And then lastly, how do we know JKL is congruent to triangle NKM. So, side, side, side postulate. Yep. Oh, I'm going to drop kick this thing to the moon. If it doesn't get its act together soon. Side, side, side. What's wrong? SSS. All right, ready to go next one? Hooray. Maybe. Maybe. You don't get bracelets. I'm not your lacrosse coach. Be a dude. Yeah, it says that. Be a dude. You're not a baseball guy. You ain't not. That's great. Swag, swag. We get some swag. What? So? Okay. All right. Number 3. So number 3 has something that when you guys do these proofs, and when you do next unit's proofs, and when you do unit 7's proofs, that you're going to see a lot. All right, they told me AC is congruent to AD. So let's go ahead and mark that up on our figure. AC is congruent to AD. What's wrong, guys? And then CB is congruent to BD. Silly old Will. So hold on, I'll write it in there for you. Because you guys will never have to do a completely blank one. Because I'm me. Why?
Coach, I was trying to do it.
Were you? Well, keep trying to do it, son.
I don't know.
Okay. Yep. Yeah, y'all will never have to go completely blank. All right, as soon as this rascal catches up. So, ladies and gentlemen, how do we know AC is congruent to AD? I guess, hold on, I'll let y'all write so y'all can finish writing this up on the left.
It's given.
Hold on. Hold on.
Chill.
Hold your horses, Sonny. One more time. Yes, it does. Yes, sir, it does. Yes, sir, yes, sir, yes, sir, yes, sir, yes, sir. What's wrong, chica? Are you okay? Yeah. Okay. Was it the AB is congruent to AB? Yeah. Okay. That's the key. Good. Hold on to that thought.
We're not finished, Cole.
Yeah, Cole. I'm all jacked up on Dunkin' Donuts.
I'm all jacked up on that too.
I'm gonna come at you like a spider monkey, Chip. I threw some of Grandpa Chip's war medals off the bridge this morning. All right. What? Oh. All right. How do we know AC is congruent to AD? They told us. How do we know CB is congruent to DB? Given. Now, this is your Hey, stay with me, weirdos. Guys, y'all will see this over and over and over and over and over. And you'll look at me like, I don't have enough information. And I'll be like, yes, you do. Now, when I look at this, AB is congruent to AB. Think about the property that you see. If we're just talking about math, what do you guys see? AB is congruent to AB. So symmetrical is when we rewrite it. Reflexive. So this is the reflexive property. Okay? And it's the reflexive property because it's the same thing, right? You guys agree that it's the same thing?
Yeah.
This is called, ladies and gentlemen, a shared side. A shared side. You're going to see it over and over and over. They'll hit you with a shared side. Property of congruence. A shared side will always be Hey, I just need you to come sit down, brother. Hey, I can't touch you. You're in my bubble. Get out of the bubble. I don't. Go sit down before I drop kick you. All right, so shared side. Anytime two triangles or two squares or two parallelograms or two whatever have the same side, no matter what happens, that side length will always be the same. If it is a shared side, that is always a congruent segment. Because AB and triangle ABC and AB and triangle ABD are the exact same. You will see reflexive shared side over and over and over. All right, and then, so how do we know that those two triangles are congruent now? Side, side, side postulate. Shared side is always reflexive. All right, so that's our first theorem we're going to talk about. Our next one is SAS. The thing that our gentleman in the back gives me every morning, a little bit of SAS. We didn't say any names. Exactly. All right, side and side, it's two congruent sides, and the biggest thing is it's the two congruent sides and the included angle. When I say included, what do y'all think? Okay. So if your parents are including you in something, what are you doing? Like if they include you in their dinner plans, y'all are going to dinner together. So an included side is where my two congruent sides come together. Okay, so included angle. It can't be an estranged angle over here by itself. It needs to be the one where my two sides come together. So it needs to be the one that's in the middle. Do. So when I look at my picture, when I look at my diagram, ladies and gentlemen, AB is congruent to DE. AB is congruent to DE. It's a vertice. All right. How do I know those two are congruent? They both have a single tick mark. Good. BC is congruent to EF. How do I know? They both have a double tick mark. And then lastly, B is congruent to E. How do I know? Nope. The hoop. Hoop. There it is. Okay. What he said. Oh, Peter. Oh, Peter. So we've got AB is congruent to DE. We've got, which is our congruent angle relationship? Angle B is congruent to angle E. And then lastly, that's what, blue? Yeah. And lastly, we've got BC is congruent to EF. So I've got a side, an angle, and a side. That means that because we have two congruent sides and the included, no such thing as angle side side. It is. We're not talking about it. All right. It's got to be the one where my two congruent segments come together. Do. What? Okay. So so we always write the first one in alphabetical order. So triangle ABC is congruent to DEF. So it's two congruent sides and the included congruent angle. Come on, you rascal.
Hit it again.
Hit it again. Oh, it's going. See, it's the threatened. Hey. There you go. What, son? All right. So you guys think this is important or what? It says included means between the sides. Included is between the sides. Where my congruent sides come together. Come together. Right now. Yes. All right, here we go. JM is congruent to LN. Mark that up on our diagram. Bless you. JM is congruent to LN. Single tick mark. All right. Come on. Okay. Angle. JMN. Come on.
Okay, I have a question.
Yes.
Like, could I start with JMN and put the single tick mark on those, and then go to JMN?
Well, angles don't get tick marks, right? They get what? Oops.
But if I were to do like the little side thingy.
The side thingy. Sure.
Okay.
Oops. So JMN gets a single hoop, and LMN gets a single hoop. So remember, we just go right in order how that rascal tells us. If it says LNM, that's where we draw our angle. We just follow along. It's like tracing our papier. Paper, son, paper. So we get JMN is congruent to LMN. Oh no. Take that thing. All right. So how do we know segment JM is congruent to segment LN? They told us. Hey. And then again, it helps if we just say, well, that's a side. Let's put an S in there. How do we know angle JMN is congruent to angle LMN? It's also given. They told us so. In the future, we'll be able to prove that using our parallelogram theorems, but that's coming. That's an angle. MN is congruent to NM. How do we know? It's not symmetric. They just rewrote it around. It's Why is it congruent?
Because they equal the same thing.
But why do they equal the same thing?
Because they're congruent,
No, sir. Why do they equal the same thing?
because they have the same angle.
Nope.
Because they're the same.
What do you mean they're the same?
They have the same boots.
Nope.
They have the same line that they got.
It's the same line. What do we call it when it's the same line?
Supplementary.
Almost.
That's congruent.
It is a,
Complementary.
stop just yelling random words. I like your vocabulary though. MN and NM is a shared side.
Oh.
I told y'all they're going to pop up a lot. What do we call a shared side? Reflexive.
Did you just take it out of the proven thing, like on the given and proven?
So technically this is not given to us because they didn't mark it on the diagram. So we have to conclude that it's reflexive because it's a shared side.
Yeah, but we took it out of the proven.
We took it right here. Right? That's our congruent segment because it's a shared side. What are y'all doing? Oh, yeah, sure. It doesn't matter. We're good. So that's a side or an angle? Side. So why is triangle JMN congruent to triangle LNM? Side, angle, side. So tomorrow we're going to mix them up a lot. What are you doing?
What are you looking at?
Please don't throw stuff on my roof. Uh-huh.
You're trying to take a pencil in the room.
You saw it? Oh, all right. AB is congruent to CB. Let's go ahead and mark that on our diagram. Bingo, bongo. So that's in yeller. Go ahead and highlight that rascal in yeller. BD bisects angle ABC. What does it mean to bisect something? Cuts it in half. So if it's bisected, what do we know about the two angles it creates? They are congruent. So I could say ABD, so ABD is congruent to CBD. All right, any more given we can use? Nope. We don't know that. We could prove it, but we don't know that. All right. How do we know AB is congruent to CB? They gave it to us. That's a side. How do we know BD bisects ABC? They told us. All right. Stop. How do we know angle ABD is congruent to angle CBD? Stop, son. Hey. What is it? Definition of angle bisector, because that's what an angle bisector does. Hey, remember, we are adults, so we don't have to get hung up on fifth grade funniness.
I'm still back in fifth grade.
I don't doubt that, but we are young adults.
Oh, yeah.
Hey, holy shit.
You mobbing. Oh. Hey, do it. You can take that to the fence. We can still see his
All right. BD is congruent to BD? How do we know that? Why is it reflexive? It's a shared side. Good. Yeah, it's about to be drop kick a clock, so.
Oh, dude.
Reflexive property of congruence, shared side. So we've got a pair of angles and two pairs of sides. So how do we know ABD is congruent to CBD? Side angle side. Remember what you were talking about earlier? It's about to show up. B is the midpoint of WZ and XY. I love when they do that. So we got B is the midpoint of WZ, and B is the midpoint of XY. So if B is the midpoint of WZ, what does that mean? What do you mean in the middle? It makes two congruent lengths. Good.
There's a vertical angle in there.
We're talking about the given information right now.
Well, I'm just letting you know.
Hey.
Thank you.
That vertical angle doesn't do you any good unless you get that these segments are congruent, brother. All right, that's fine. Here we go. So, V is also the midpoint of XY. What does that mean? Nope. My sides are congruent, yes. So that cuts my two segments congruently. I do not necessarily know that they are congruent to each other, or the other ones. All right, so that's all our given information. V is the midpoint of WZ and XY. How do we know? They told us. How do we know WV is congruent to ZV? Midpoint. That's how we concluded that they were congruent. WVX is congruent to ZVY. So that's saying that these two angles are congruent. Those are vertical angles. Thank you, Cole, for being the first one to say that. He actually did say it before you got to school. Before he got to school. Okay. So that is a vertical angle theorem. Vertical angles are always congruent. Okay. And then how did we know XV is congruent to YV? But why? Definition of midpoint.
They have the same amount of tick marks.
But why do they have the same amount of tick marks?
Definition of congruence.
Nope. Definition of midpoint. He does not. All right, so how do we know WXV is congruent to triangle ZYV? Side angle side. Little sass. Last one? Yep, last one. It is the last one. HI is congruent to JG. HI, JG. It will make them parallel, but you don't know why yet. But we'll learn it. Oh, they told us it was parallel. My man. Ooh, I like this. It is also parallel.
So is that a transversal line in there?
It would make that HJ a transversal. By definition, that could become a transversal. I like that, dude.
Who said that?
You did, brother. All right, so that would be a transversal. So how did we know HI was congruent to GJ? Given? How did we know they were parallel? Also given? How do we know that, what is it, GJH? What is it? GJH, so GJH is parallel to IHJ. What makes this congruent to that? And you need to go back to what my man in the back said about the transversal with some parallel lines. Which of our parallel lines theorems can we use to say that those two angles are congruent?
Alternate interior.
Alternate interior angles. Very good, dude. Alternate interior angles. They are congruent because of alternate interior angles. Why is HJ congruent to JH? Why? Shared side. It's a shared side. So because it's a shared side, it's reflexive. I'm telling y'all, that thing's going to show up a lot. And then lastly, what makes my triangles congruent? Side angle side.